Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the various forms of logical expression such as the sum of product form and the product of sum form. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of Minterms and Maxterms. For that purpose, let's revise our previous lecture. In that lecture, we have seen the SOP equation and POS equation. The SOP equation means it sum of product. That means here the product terms are added together, and in POS equation the sum terms are multiplied with each other. It is known as the SOP and POS form. Now let's start our today's topic, min terms and max terms. Each individual term in canonical SOP is called as the min terms. That means this is the example of canonical SOP. That means y is equal to a into b into c plus a into b bar into c bar plus a bar into b plus c bar. Here this equation is in canonical form, and each individual term, that means this term and this term, these terms are called as the min terms. Each individual term in canonical SOP is called as min terms. That means ABC, A B bar C bar, A bar B C bar, these are the min terms. Now let's see what is meant by max terms. Each individual term in canonical POS form is called as max terms. Here this is the equation of canonical POS. That means y is equal to in bracket a plus b into second bracket a plus b bar. Here each sum term or each individual term, that means a plus b, is called as the max term. A plus b bar is called as max term. I hope you all now understand what is meant by min terms and max terms. Okay, let's see once again. If we have the equation y is equal to a bar bc plus abc plus a bar b bar c bar, then this is the example of canonical SOP, sum of product. In canonical SOP, each individual term, that means this term and this term, these terms are called as the min terms. Okay, and if we have the equation y is equal to a bar plus b plus c into a plus b plus c into a bar plus b bar plus c bar. This is the equation of canonical POS, and each individual term in canonical POS, that means this term and this term, is called as the max term. I hope now you all understand what is meant by min term and max term. Let's see the min terms and max terms for three variable or three literal logic function. That means we have the three inputs here, a, b and c. Their possible combinations are 0 0 0 to 1 1 1. Okay, let's see the min terms and max terms of these three variables. That means if a has the value 0, b has the value 0 and c has the value 0, then we can write the min terms as mi. A has the value 0, hence we write here a bar. B has the value 0, hence we write here b bar. C has the value 0, hence we write here c bar. That means this is the first min term labeled as m0. Okay, let's see the next condition. A has the value 0, hence we write here a bar. B has the value 0, hence we write here b bar. C has the value 1, hence we write c. That means a bar b bar c. A bar b bar c is labeled as min term m1. The next is a has the value 0, that means a bar. B has the value 1, that means b. C has the value 0, that means c bar. That means we get a bar b c bar. A bar b c bar, this is m2. Okay, The next condition is that A has the value 0, that means A bar, B has the value 1, that means B, C has the value 1, that means C, that means we get A bar BC. A bar BC is M3. Okay. The next condition is that A has the value 1, that means A, B has the value 0, that means B bar, C has the value 0, that means C bar, that means we get here A, B bar, C bar, M4. The next condition is that A has the value 1, that means A, B has the value 0, hence B bar, C has the value 1, that means C. We get here A, B bar, C, that means min term M5. The next condition is that A has the value 1, that means A, B has the value 1, that means B, C has the value 0, that means C bar, A, B, C bar, that means min term 6. Okay. Similarly, A has the value 1, that means A, B has the value 1, that means B, C has the value 1, that means C. We get here A, B, C, that means min term 7, M7. Okay. I hope you all understand how to write the min terms. For example, let's see once again A, B, C, and D. These are the four literals, and A has the value 1, B has 0, C has 1, and D has 0. We can write the min terms of these combinations such as if A has the value 1, then we can write A. B has the value 0, hence we write here B bar. C has the value 1, hence we write C. D has the value 0, hence we can write D bar. Hence we get the min term A, B bar, C, D bar. That means if the literal has the value 1, then we can write as it is. But if the literal has the value 0, then we can write its bar, A bar. Okay, I hope you all understand how to write min terms. Now let's see how to write max terms. Whatever the process done in writing min terms, the opposite is done while writing in max terms. That means in min terms, we write if A has the value 0, then we write A bar, and if A has the value 1, then we write A. But this is done in min term. But in the case of max term, if A has the value 0, then we can write here A, and if A has the value 1, then we write here A bar. This is in the case of max term. Okay, that means A has the value 0, that means we have to place here A. B has the value 0 means B. C has the value 0, that means C plus. Okay, we get here max term A plus B plus C. This is M0. The next case is that A has the value 0, that means A. B has the value 0, that means B. C has the value 1, that means we have to write C bar. A, B, C bar. Okay, that means M1, max term M1. The next condition is that A has the value 0, that means we have to write A, plus B has the value 1, that means we have to place B bar. C has the value 0, that means C. We get A, B bar, C. A, B bar, C. It is max term second M2. The next condition is that A has the value 0, that means we have to place A, plus B has the value 1, that means we have to place B bar, plus C has the value 1, that means C bar. We get the max term A plus B bar plus C bar, A plus B bar plus C bar, which is max term 3, M3. The next condition is that A has the value 1, that means A bar, plus B has the value 0, that means B, plus C has the value 0, that means C. We get the max term A bar plus B plus C. A bar plus B plus C, which is max term 4, M4. The next is that A has the value 1, that means A bar, plus B has the value 0, that means B, plus C has the value 1, that means C bar. We get the max term here A bar plus B plus C bar, A bar plus B plus C bar, which is max term 5 or M5. The next condition is that A has the value 1, that means A bar, plus B has the value 1, that means B bar, and C has the value 0, that means C. We get the max term here A bar plus B bar plus C. a bar plus b bar plus c, that means m6. Okay. In the last combination, a has the value 1, that means a bar, plus b has the value 1, that means b bar, and c has the value 1, that means c bar. We get the max term here, a bar plus b bar plus c bar, a bar plus b bar plus c bar. I hope you all now understand how to find the min terms and max terms for the given truth table. Okay, let if we look at the table, then we can notice here that the mean terms are written in the small letters m0, m1, m2, while the max terms are written in capital letters m0, m1, m2, etc. Okay. Now let's see the truth table for two variable min terms and max terms. If there are only two variables, that means a and b, then the possible combinations of the a and b are 0, 0, 0, 1, 1, 0 and 1, 1. Okay. We can write the min terms. We know that in the case of min terms, if a has the value 0, then let's see once again. If a has the value 0, then we can write a bar, and if a has the value 1, then we can write only a. That means in case of min terms, a has the value 0, hence we write here a bar, b has the value 0, hence we write here b bar, we get a bar b bar as min term. Here in this case, a has the value 0, hence we write a bar, b has the value 1, hence we write b, hence we get the min term a bar b. We get the min term a bar b. Next, if a has the value 1, that means a, and b has the value 0, that means b bar, we get the min term a b bar. Both having value 1, 1, that means a and b, we get the min term as a into b. Similarly, we can write the max terms such as in the case of min term, we are written as a bar is equal to a is equal to 0. That means in the case of min terms, we write here if a equal to 0, then we write a bar. If a equal to 1, then we write a. But in the case of max term, the condition is now opposite. That means when a equal to 0, we can write it is as a, and if a is equal to 1, then we can write a bar. Hence, in this table, the first condition is that a is 0, that means a bar, plus b is 0, that means b bar. We get, sorry, one mistake here. In the case of max term, we write if a equal to 0, then is it as it is a, and if a is equal to 1, then we can write the a bar. That means a is equal to 0, that means we have to write a, b is equal to 0, that means b. We get the max term a plus b. Here a is equal to 0, that means a, b is equal to 1, that means b bar, hence we get the max term a plus b bar. Here a has the value 1, that means a bar, b has the value 0, that means b. We get the max term a bar plus b. Here both the variables has the value 1, hence a is 1, that means a bar, b is 1, that means b bar, a bar plus b bar. These are the max terms. I hope you all understand how to write the min terms and max terms for the given combination. For example, let's consider once again the numbers or the variables a, b, c has the combination 1, 0, 1. We can write the min terms for it as, in the case of min term, if a is equal to 1, then we can write it as a into b equal to 0, hence we write here b bar, c equal to 1, hence we write c bar. We get the min term a into b bar into c. We can write the max term for the same, that means a has the value 1, that means we write here a bar, plus b has the value 0, hence we write here b, plus c has the value 1, that means we write here c bar. This is the max term. Okay, I hope now you all understand how to write min terms and max terms. Now let's see to write canonical SOP expression for a given truth table. The procedure to be followed for writing the canonical SOP expression is as follows. Consider only those combinations of the inputs which corresponds to the output y is equal to 1. Write down the product term for each combination, or add all the product terms, minterms, to get the canonical SOP. Let's see it on the example. From the following truth table, obtain the logical expression in the canonical SOP form. Here is the truth table is given, that means A and B are the inputs and Y is the output. The combination of 0 0 gives the output 0. Combination 0 1 gives the output 1. Combination 1 0 gives the output 1. Combination 1 1 gives the output 0. This is the output. Okay. Then we have to write canonical SOP form. We know that in canonical SOP, each individual term is called as minterm. Hence, we have to write the minterms, and we write minterms for the output 1 only. Okay. For 0, we ignore the combination. Hence, we have to write for the output 1 only. That means we have to write minterms for this one and this one. Here the combination is A equal to 0, that means A bar, B equal to 1, that means B. This is Y1. For Y2, we can write A equal to 1, that means A, B equal to 0, that means B bar. At the end, we have to add these two outputs, that means Y1 plus Y2. We get the final equation A bar B plus AB bar. Okay. I hope you all understand how to write the canonical SOP from the given truth table. Let's see once again. Consider the given truth table. Write the minterms for the output 1 only. That means for this combination, A has the value 0. That means here we can write A bar. B has the value 1. That means here we can write B. Here we get Y1 equal to A bar into B. Similarly, we can write Y2, that means here A has the value 1, hence we can write A. B has the value 0, hence we can write here B bar. We get here A into B bar, and we can write the final expression Y is equal to Y1 plus Y2, that means A bar B plus AB bar. Okay. Let's see the next example. For the given truth table, write the logic expression in canonical SOP form. In canonical SOP form, that means we have to write here minterms, and we can write the minterms for the output 1 only. For the output 0, we ignore this condition. That means we ignore this condition, and we have to write outputs for this condition, and this condition. Okay, I hope you all understand. For this one, we have the combination A is equal to 0, that means A bar. B is equal to 0, that means B bar. C is equal to 1, that means C. This is our Y1. Okay, plus the next one is A is equal to 1, that means A. B is equal to 0, that means B bar. C is equal to 0, that means C bar, plus the next output for the next one is A is equal to 1, that means A. B is equal to 1, that means B. C is equal to 1, that means C. Okay, that means we get the final equation A bar B bar C plus A B bar C bar plus ABC. That means in the form of minterms, we can write it as Y is equal to M1 plus M4 plus M7. That means we can write it as summation of M147. I hope now you all understand how to write the canonical SOP from the given truth table. Now let's see to write canonical POS expression for a given truth table. The procedure to be followed for writing the canonical POS expression is as follows. Consider only those combinations of the inputs which corresponds to output 0. In case of canonical SOP, we consider here y is equal to 1, but in case of canonical POS, we consider y is equal to 0 instead of y is equal to 1. Write down the sum term for each combination and or multiply all the sum terms or the max terms to get the canonical SOP. Let's see it on the example. Here, write the logic expression in canonical POS here canonical POS, then that means we have to write here max terms for the given truth table. That means we have here truth table A, B, C and output Y. Here we have to write max terms, hence we consider Y equal to 0 only. Y equal to 0, that means we have to write max term for this condition, for this condition, this condition. If y is equal to 1, then we have to ignore these conditions. Okay, I hope you all understand. Here we can write the max term for this y is equal to 0 such that a is equal to 0, that means a, plus b equal to 0, that means b, plus c equal to 0, that means c. Okay, into the next is a is equal to 0, that means a, plus b is equal to 1, that means b bar, plus c is equal to 1, that means c bar, into next bracket this 0. A is equal to 1, that means a bar, plus b is equal to 0, that means b, plus c is equal to 1, that means c bar, into last bracket a is equal to 1, that means a bar, plus b is equal to 1, that means b bar, plus c is equal to 0, that means c. Hence we get the final expression here a plus b plus c into a plus b bar plus c bar into a bar plus b plus c bar into a bar plus b bar plus c. Okay, I hope you all understand now how to calculate the canonical POS equation or the max terms for the given truth table. Okay, write the max terms for the combinations of the input which produce y is equal to 1. Okay, this is the very important here. We have to write the equation for y is equal to 0. In case of canonical SOP, we have to write the equation for y is equal to 1. Okay, I hope you all understand. Here there are the max terms m0, m3, m5 and m6. Hence we can write it as y is equal to m0 into m3 into m5 into m6, or y is equal to pi of 0, 3, 5, 6. I hope you all understand how to write max terms. Now let's see, for the given truth table, write the logical expression in canonical SOP and POS forms. That means in this table we have to write the logical expression in canonical SOP and canonical POS. Okay, first of all, let's consider the canonical SOP. For the SOP, we have to consider y is equal to 1. Here we get y is equal to 1. Hence we can write the minterm for this as a is equal to 0. Hence we write a bar. B is equal to 0. Hence we write b bar. C is equal to 1. Hence we write c. Again we get here y is equal to 1. Hence we write minterm for same. A is equal to 1. Hence we write a. B is equal to 0. Hence we write b bar. C is equal to 0. Hence we write c bar. Again here we get y is equal to 1. The mean term for the same is that a is equal to 1, hence we write a, b is equal to 1, hence we write b, and c is equal to 1, hence we write c. Okay. Hence we get the mean terms as a into b into c. Now we have to write the max terms for POS equation, and for the POS equation we know that we have to place or we have to find the max terms for y equal to 0. Here we get y equal to 0, hence we can write the max term for this combination a equal to 0, hence we write here a, b equal to 0, hence we write here b, c equal to 0, hence we write here c. Hence we get the max term as a plus b plus c. Next, here we have y equal to 0, hence we can write the max term for this combination. Here a equal to 0, hence we write here a, b equal to 1, hence we write b bar, c equal to 0, hence we write c. We get the max term as a plus b bar plus c. Here also the y is equal to 0, hence we can write the max term for this combination. A is equal to 0, hence we write here a, b is equal to 1, hence we write b bar, c is equal to 1, hence we write c bar. we get the max term a plus b bar plus c. Here y is equal to 0, hence we can write the max term for this combination. A is equal to 1, hence we write a bar. B is 0, hence b. C is 1, hence c bar. We get the max term as a bar plus b plus c bar. Here also y is equal to 0, hence we can write the max term for this combination. A is equal to 1, hence we write here a bar. B is equal to 1, hence we write b bar. C is equal to 0, hence we write c. We get the max term as a bar plus b bar plus c. I hope you all now understand how to find the min terms and max terms for the given truth table. Now let's consider write down the canonical SOP form for the following table. We have to write canonical SOP, that means we have to write min terms for the table, and when we write min terms then we consider the output y is equal to 1 only. Okay, here y is equal to 1, hence we can write the min term for this combination such that a is equal to 0, that means we get here y1 as a bar into b is equal to 1, that means b, into c is equal to 0, that means c bar. Here also we have y is equal to 1, hence we get here y2. For this combination a is equal to 0, hence we write here a bar, into b is equal to 1, hence we write b. C is equal to 1, hence we write here c. We can also find the min term for this combination y is equal to 1. Here we can write y3. A is equal to 1, hence we write here a. B is equal to 1, hence we write here b. C is equal to 0, hence we write here c bar. Similarly, we can write y4 for this combination such that a is equal to 1, that means we write here a. B is equal to 1, that means we write here b. C is equal to 1, that means we write here c. We get the min terms as y1, y2, y3, y4 such that a bar b c bar, a bar b c, a b c bar, a b c. Okay, we can write the canonical SOP equation such that a bar b c bar plus a bar b c plus a b c bar plus a b c. Okay, I hope you all understand how to write min terms. We can write this SOP equation such that, for example, let's consider this is min term 0, m1, m2, m3, m4, m5, m6, m7. Hence we write the equation for y is equal to m2 plus m3 plus m6 plus m7. I hope you all understand how to write the canonical SOP from the given truth table. Now let's consider write down the canonical POS. That means we have to write max terms, and when we write the max terms we consider y is equal to 0 output. That means y is equal to 0. For that combination we can write the max terms, hence here we can write y1 such that a equal to 0, hence we write here a, plus b equal to 0, hence we write here b, c is equal to 0, hence we write here c. Again, here we get y is equal to 0, hence we can write here y2 such that a equal to 0, hence we write here a. We write here a only, plus b is equal to 0, hence we write here b. C is equal to 1, hence we write here c bar. Here also we can write the max term y3. For this combination a is equal to 1, hence we write here a bar, plus b equal to 0, hence we write here b. C is equal to 0, hence we write here c. For this combination, that means we can write y4 such that a is equal to 1, that means a bar, plus b equal to 0, that means b, plus c is equal to 1, that means c bar. This is the canonical POS equation, that means a plus b plus c into a plus b plus c bar into a bar plus b plus c into a bar plus b plus c bar. This is the canonical POS expression. We can write the expression in another way such that y is equal to, this is m0, m1, m2, m3, m4, m5, m6 and m7. Okay, here y equal to 0, hence we write here m0 into m1 into m4 into m5. I hope you all understand how to calculate min terms and max terms for the given table. Thank you.